Hey YouTube, what's going on? We are on differentiation, A-level maths. So this is the right time to understand how to differentiate from first principles. So using definition, how to find derivative exactly for your function. So make sure you watch the previous video where we discussed the principle. The principle is actually for differentiation, how we denote derivative as the prime f dash or dy dx. So no matter which notation you use, questions you might be asked and given different, notations, make sure you can operate with them. If you are not, if you have no idea what f prime means of this apostrophe or dash, so please watch the video, watch the previous video where I explain actually how to differentiate from the first principle in a general way, okay, where this formula comes from. Okay, and now if you're ready to do that, let's discuss several examples so that you might probably meet on your interim tests, so or even on the exam. So I pick up like different questions that somehow actually relates to the powers, because that's the first. You start your differentiation from actually powers and techniques that you need to be able to apply first to derivatives. Actually, so to the powers, to equations with powers. And that was the problem for many students on GCSE. So that's right time to recap everything there. Okay, so for this function, you need to find dy dx from first principles. All right, so dy dx means the same as you trying to take derivatives. So that's why dy dx simply means that you need to take y dash, right? And given point x. You're not given the point itself, but you need to assume that you need to find derivative for the function in some like random point x. Okay, let's go by definition. So if this is fx plus h minus of x, when we take in the limit of h close to 0. So we're writing just by definition every time you need to write this formula, every time. So you plug your y from x is x squared. So that's why, as you can see here, you need to plug the argument x plus h. So that's why instead of x, you just plug in x plus h. And if you do that, you'll have, as a result, x plus h squared. That's how function works, right? You have an input and you have output according to the rule that function gives to you. Okay, so that's why we will have x plus h, which is squared, and then we take away f from x. So, but f from x is normal x, okay, x squared. So that's why we divide it finally by h. Okay, so you cannot take and say that, okay, let's plug instead of h0, you will violate the rule because you will be divided by 0. So that's why first, simplify completely or in full, okay? So that means I'm saying about expanding those brackets, but instead of doing that, I'll better use the formula. So x plus h minus x and x plus h plus x, right? That's a well-known formula, all right? So that's why we taken still the limit h close to 0 and we still divide by h. All right, so what we have, x and x will be cancelled, so we stay with h, and we'll get x plus x is 2x plus h over h. And we're still taking the limit. Always we need to write this sort of prefix, all right? Now what we're gonna do, now we can cancel our h here and here. You ask me why? Because h is not 0. So h tends to 0, but h is not that 0, and that means you can freely cancel. That's the difference between actually plugging the value h equals 0 and the limit, okay? H is very, very close to 0. So hopefully we can find dy dx that also means prime or y prime, f prime, no matter how you use that, which notation you use, and you're left with 2x plus h with the limit. So limit h close to 0, 2x plus h. Finally, you'll get, now you're eligible to plug h equals 0. So this is transition that you need to understand. Finally, eventually, you need to plug h equals 0, so you'll get 2x plus 0, and finally, that's 2x. For those who are already know techniques how to use differentiation, so if we can test that, f prime is going to be equal to x squared prime. That's you actually supposed to do on your GCC. So that's why it's going to be just simply 2x, because according to the rule, x to the power of n prime is going to be n x n minus 1. So that's why you'll have power n equals 2, and that's the result. So that's the final result, dy dx equals 2x. So we've got the right answer. But we use definition. So that means, in other words, you are not supposed to apply this technique, but you can check. That's the hint for you. So use that hint, because it's a very useful way to check your answer finally. Let's go to the next one. You need to differentiate fx equals square root of x. Okay, from the first principle. In other words, you need to find again f prime. In this case, I'll accelerate a bit. So we take in f prime, so we just go on by definition, we plug in x plus h argument according to our formula. We subtract square root of x and we divide by h, and we take in the limit before as prefix. All right. So right now, that's what we have. How to cope? You cannot cancel, you cannot do anything, because in this case, you're not having any formula. Literally say there is nothing to do. That's why it's confused for many students. It's really confusing for many students. But just remember that you can remember surds, how to work with surds. You can rationalize, but in the case of surds, you mostly rationalize denominator. So rationalize denominator. Okay? In this case, you need to swap into numerator, because in denominator there is nothing to rationalize, just h only left. So that's why you're multiplying by conjugated. So what it means? It means that you're still taking the limit, h is very close to 0, and now you multiply by x plus h minus square root of x by conjugated, the same structure but the opposite sign. That was minus, now it's plus. Okay, and here's in the bottom part you'll have the same for not to change the fraction, plus square root of x. Okay, as you can see, you can freely cancel both factors, and your fraction hasn't been changed in this case. All right, so you're taking the limit when h is very close to 0, and now what you're going to do, you apply the formula a minus b, a plus b. So finally you'll get x plus h squared. You eliminate that. Normally you need to use modulus, but initially x plus h is positive but very close to 0, so by definition domain for this function x more equal than 0, so you can't get rid of those modulus or absolute values, and you take away x. You still divided by h times square root x plus h and plus square root of x. Okay, so you've got this, and finally you'll take away x's, you cancel them, you're left with h on top, and that's why you're taking the limit h close to 0. H and h will be cancelled in this case, and you stay with the expression only in the bottom part. So x plus h and plus square root of x. So finally, you'll get, taking the limit, now there is nothing spoil you plug in h equals to 0. That won't spoil your equation or violate somehow, so that's why you just simply plug h equals 0. That's the final transition here, and you'll get 1 over 2 square root of x. Okay, so now let's check it. Remember, we check it always, so that's why we take an f prime, and this is equivalent to x1 over 2 prime. So now you take in 1 over 2, and you take away the power. 1 over 2 minus 1 is going to be x to the negative 1 over 2. But negative, the same as you swap your x and take in the square root, right? Because that's the rule of indices. So f prime is going to be 1 over 2 square root of x. So that's why we were correct, and hence we can actually use that. So that was differentiation from the first principle, but I would like to have the last example. That's pretty easy. So you need to prove that from the first principle, x squared plus 1 is 2x. All right, so we need to prove that f prime finally is going to be 2x. Now let's try to do very, very fast. We just plug in x plus h into the formula, which is simply squared, then plus 1 in the end, and we subtract x squared plus 1, your original function, we divide it by h, and we apply the limit when h is very close to 0. Okay, so as you understand now, if you're actually very confident of the previous examples, now we just do it technically. So what we're gonna do, x plus h squared, so, and minus 1 will be cancelled, and I just simply again repeat what I had, x plus h squared minus x squared over h. And let's have a look at the expression. Just go back a little bit. We have already that before, and we proved that the result of this is 2x, right? So that's why we can say that this is going to be 2x, but I'll show you in a quick way. So limit h close to 0. Now in this way, in this case, I'll just simply expand. So using another formula, x squared plus 2xh plus h squared minus x squared, and over h, x squared will be cancelled, and you'll get 2xh and h. So I factorized h in this case, and I'm left with 2x plus h finally over h. H will be cancelled, h is going to be 0, so finally you'll get 2x. So done. All right, that's how you can master your differentiation from first principle. Of course, that's not complete, so please check out my A-level differentiation from first principle as a revision. So this video is going to be soon. Okay, and don't forget to visit A-level Zillion's classes. He has also lots of stuff dedicated to A-level. Check them out. All right, that was Daniel Dallas. Hope you see you next time. Peace.